Okay, some people ask, hey, we want a thickness tester that can measure through coatings. We don't necessarily need the A scan, but that's how we know and we've got confidence in the readings. Have you got anything else? Well, in fact, we do. Let's check it out. We'll compare what an entry-level thickness gauge and a through-coating thickness gauge that's still entry-level will give you accurate, reliable readings, but still not blow the budget. All right, what I'm going to show you now is the CTS30A and the CTS30C. This is the basic unit. This is the unit that has got a much better probe that can work through coating. So I'm going to take a reading now of this plastic shim. It's approximately 0.5 millimeter thick. Okay, what I'm going to show you now is the difference between the CTS30A and the CTS33, where this has a through coat mode. So we've taken a measurement with our verniers of these plastic shims. We know that this particular unit will measure accurately the material. What we want to do now is simulate a coated surface. So if we make sure that there's oil underneath, there's oil on top, we take a reading. It's having difficulty trying to determine what the thickness is. Is it the total thickness of the material plus the coating, or is it just the coating? And it can't determine the difference. What I'm going to do now is take the CTS33 and the highest specified probe, and what it will do is it will measure through the coating. So it's taking into account the coating thickness, the material thickness, subtracting it, and then just giving the remaining wall of the material underneath. And that works really, really nicely. No interruptions. And so if there was no coatings, still works great. So that's how the through coat moding, without knowing all the mathematical formulas that are going on and the electronics that are going on inside the probe and the instrument, that is a demonstration of how it would work through coatings. So if you're going 0.5 mil coating and you're not quite getting consistent readings from your other devices, this is most likely what's going on. It can't take into account the new velocity of the material or the coating, and it can't factor that into the device. And that's why you might need to step up to something a little bit more powerful. Have confidence that your readings are accurate, even through coatings.